I am Dr. Binu for the fundamentals of electrical and electronics engineering. The fifth topic is rectifiers. Rectifier is an electronic device which converts alternating current into direct current by means of using PN junction diodes. There are varieties of rectifiers are available, uncontrolled rectifiers as well as controlled rectifiers. Uncontrolled rectifiers are the type of rectifier whose voltage cannot be controlled. But in the uncontrolled rectifiers, two varieties or two subdivisions are there: half-wave rectifier as well as full-wave rectifier. In the full-wave rectifier, both the positive as well as negative half cycles of the AC is converted into DC. But in the half-wave rectifier, only the positive half cycle is converted into DC. In the full wave rectifier, one more variety is there, the full wave rectifier with 2 diodes as well as 4 diodes. The 4 diode combination of the full wave rectifier is called as bridge rectifier. In this circuit diagram, the connection of 4 diodes are called, looks like a Wheatstone bridge, so it is called as bridge rectifier. In the controlled rectifiers, instead of using PN diode, we can use ACRs, MOSFETs as well as IGBTs. In the uncontrolled rectifiers, half wave as well as full wave rectifiers. Here we know the basic definition. Rectification is conversion of AC into DC. Half wave as well as full wave rectifiers is the types. The third one is bridge rectifier, half-wave rectifier. In half-wave rectifier, either positive or the negative half of the AC is converted into the DC. The another half is blocked. So this method, the efficiency is less than 50%. So this method is not mostly used. We are going for full wave rectifier. The circuit diagram for the half-wave rectifier is represented here. The representation, the working is represented in the animation pattern. Here, whenever the positive circle is passed through the diode, here the diode will be acting as a switch in a closed position, so it allows the positive cycle to the output, while the negative half cycle of the input waveform is given to the circuit. Now the diode will be acting as a reverse biasing. At this time, the diode will be acting as a switch in an open position, so which will not allow the output to that is the negative half to the output. So the output is nothing but only having the positive values, the negative values are only zeros. The circuit diagram as well as the input as output waves are represented for the half-wave rectification. The output DC voltage is calculated by means of Vrms is equal to V peak divided by 2, Vdc is equal to V peak divided by pi formulas. What is meant by full wave rectification? In the full wave rectification, a center type transformer is used as well as two diodes are connected in back to back, which can form the full wave rectifier. The circuit diagram as well as input output waveforms using two diodes is represented in the circuit diagram. Here, whenever the positive cycle of the input is given to the circuit, diode D1 will be forward biased, so it allows the input to the output. At that time, diode D2 will be acting as a reverse bias, but in the negative half of the input is given to the circuit, the diode D1 will be acting as a reverse bias, but diode D2 will be acting as a forward bias. so which allows the circuit, that is input, to the output. So finally, for the both the half cycles are available in the positive of the output side. The formulas for the full wave rectification, the conversion of the half full wave rectifier is shown in the animated waveform. This diagram is nothing but with the 4 diodes, that is the diode connection is in the bridge rectifier form. In the positive half cycle, the diodes D1, D3 will be conducted. In the negative half cycle, diode D2 and D4 will be conducted. So the output will be in the positive side. The input waveform as well as output waveform for the 2 diode full wave rectifier is represented in the circuit diagram. This is the working of the full wave rectifier. The formulas for the full wave rectifier are shown. The DC output voltage is VDC is equal to I average into RL, which is nothing but 2 divided by pi into I max into RL. The RMS value of the current is equal to I max divided by root 2. The form factor of the full wave rectifier is nothing but RMS value of the current to average value of the current, which is nothing but 1.1. The peak factor of the full wave rectifier is, it is the ratio of peak value of the current to RMS value of the current, which is nothing but root 2. The efficiency for the rectifier is nothing but rectification efficiency, which is the DC output power divided by AC input power. VDC is equal to V average is equal to 2 Vp divided by pi. Vrms is equal to Vp divided by root 2. The output voltage for the full wave rectifier is shown in the animated video. There are several advantages of full wave rectifier. The rectification efficiency is double the time of half wave rectifier. Half wave rectifiers are having the efficiency of only 40.6, but the full wave rectifiers are having the efficiency of 81.2. The ripple factor in full wave rectifiers is very low. The value of ripple factor for the full wave rectifier is only 0.482, but in the case of half wave rectifier it is 1.21. The only drawback of the full wave rectifier is they need more circuit elements, but in the half wave rectifier the circuit elements are very less, but because of the higher needs in more components, the full wave rectifier is costlier compared to half wave rectifier. Bridge rectifier. Here the 4 diode arrangement is looking like a Wheatstone bridge, so it is called as bridge rectifier. The connection diagram is represented in this manner. The working model of the bridge rectifier is shown in the animated video. The general applications of rectifier. Rectifiers are used in electrical welding. Normally half wave rectifiers are used in mosquito repellent, which is also used as signal peak detector in AM radio. Rectifiers are used in modulation, demodulation, as well as voltage multipliers.